Hey guys, this is my first attempt at recording a video for you for our next unit, which is on trig. So this is chapter 9.1. We're going to start out with just a basic overview of the 6 trig functions. So you guys, in geometry, I know you learned about SOHCAHTOA, right? So the sine of an angle is equal to the opposite over the hypotenuse. The cosine is equal to the adjacent side over the hypotenuse, and the tangent is equal to the opposite side over the adjacent side. So what exactly does that mean, hypotenuse, adjacent, opposite? Well, trig, as we know, just works with right triangles. So if I have an angle here, I'm calling this top angle my angle. I could have done this one, but I chose this one. So if I look at this angle, the side opposite that angle is called the opposite side. Adjacent means next to, so the side next to my angle is called the adjacent. Now some of you may be saying, well, but this side's also next to the angle. Well, the side opposite the 90 is always called the hypotenuse. That might be something you guys already learned. So if I have this, we'll call this angle A here. If I want to take the sine of angle A, I'm going to make a fraction opposite over hypotenuse. The cosine is going to be the adjacent over the hypotenuse, and the tangent is going to be the opposite over the adjacent, which is why we have this little mnemonic SOHCAHTOA. Now maybe you didn't know this, but there are actually 3 more trig functions, and they're called the reciprocal trig functions, and that's because we get them by just flipping over our 3 first trigs, the SOHCAHTOA trig functions. So to get if I flip sine over and make it hypotenuse over opposite, it's called cosecant, CSC. Now if I flip sine over, or cosine over rather, I get secant. So if cosine's adjacent over hypotenuse, if I flip it over, I get hypotenuse over adjacent. If I flip tangent over, right, and make it adjacent over opposite, I get the cotangent. So even though this seems like a really kind of a lot of info, all it is just flipping the original trig functions. So I'm going to do example A. I don't have my 6 boards, so you guys will have to bear with me here. First example. Okay, the first example says find the 6 trig functions. And they give us a triangle, and it looks like this. And if you notice, they're only giving us 2 sides, right? We know this is the hypotenuse, but we don't know its length. So what we have to do in order to find the first part, in order to do our 6 trig ratios, we have to use the Pythagorean theorem, which we know works on right triangles, to find the missing side. So you guys remember the Pythagorean theorem? I'm sure you do. A squared plus B squared equals C squared. So we'll call this A, this B, and this C. So let's fill in what we know and solve for C. So we know that A is equal to 5. So it's going to be 5 squared plus 12 squared equals C squared. Right? Once we do that, we do our exponents first. So we know 25 plus 144 equals C squared. Okay, and then if I add those up, I get 169 equals C squared. And we all know how to undo a square, and we do it by square root. So 13 is going to equal C. So that's our first step. Right, now we know that this is 13. So that now we have all 3 sides, so we can do all the trig ratios. Okay, so let's start with sine. Our angle is right here. We're going to call it theta. That's often the symbol they use for the angle. So if I want the sine of theta, I'm going to take the opposite side, which is 12, over the hypotenuse. So there's the sine of my angle. Now I'm not going to have enough room to go across, so I'm just going to go up and down. The cosine of theta, our angle, is equal to the adjacent side, which is 5, over the hypotenuse, which is 13. The tangent of theta is equal to the opposite side of theta over the adjacent side. Okay, now we're going to find the 6 reciprocal trig functions. The easiest way to do it, so for sine, the reciprocal trig function is cosecant. So rather than use the triangle, I'm just going to flip over sine. So instead of 12 over 13 for sine, we now have 13 over 12. Now the upside down reciprocal of cosine is secant. So I'm just going to flip over cosine. And my last one is cotangent, which is flipped over tangent. Oops, sorry, I didn't leave myself enough room here. Okay, so that's how we're going to find the 6 trig functions. We have our right triangle, and we can do the ratios. Here it was kind of nice because they drew the triangle for us, and they gave us 2 of the sides, and we just used Pythagorean theorem. Let's spice it up one step. This time, we are going to be told something about the triangle. We're going to be told that the sine of a triangle, of one of the angles, saying theta is acute. If you guys remember what acute means, it means it's less than 90 degrees. So it's not the 90-degree angle, it's one of the other ones. And they're telling us that sine of theta is equal to 4 over 7. So the first thing we have to do, they want us to find the other 5 trig functions. They gave us 1, right? There's 6 total, they gave us 1. Okay, so first thing I want to do, a picture's worth 1,000 words, right? So I want to draw the triangle. And we can decide wherever we want to put theta. Let's spice it up, let's vary it up a little bit, and let's make theta this angle this time. So if they're telling me that the sine is 4 over 7, what that means is this is opposite over hypotenuse. So they're saying that the opposite side is 4 and the hypotenuse is 7. So now we have the drawing the triangle, but we're still missing this side right here, which we'll call B. So we need to use the Pythagorean theorem to find B. Theorem. Okay, so let's use the Pythagorean theorem to find B. We're going to do 4 squared plus B squared equals 7 squared. Okay, let's see what we've got. We've got 16 plus B squared equals 49. And if I subtract 16 from each side, I get B squared equals 33. Right, we all know from our square roots unit, our quadratic unit, if I square root, I get B equals the square root of 33. Is anyone wondering why we're not writing plus or minus the square root of 33? Technically, in algebra, that's what we would do, but we're looking at lengths of triangle sides, so it doesn't make sense to have the negative. So now we know this is equal to the square root of 33. So we can now find our other trig ratios. So let's start with cosecant. Do you guys know why I'm starting with cosecant? Because it's the easiest to find, because they told me that sine is 4 over 7. So I'm just going to flip it over, and it's 7 over 4. Makes it pretty simple. Then we're going to go to cosine. So cosine is equal to adjacent over hypotenuse. So here's our theta. So the adjacent is root 33, and the hypotenuse is 7. Right? Then we're going to move on to secant. Okay, secant is cosine flipped over. So let's flip over cosine, and we're going to go, oh, wait a minute, we remember something about how we can't leave a square root on the bottom of a fraction. So if you guys remember, what I'm going to do here is multiply both the top and the bottom by the square root of 33. And the reason is because the square root of 33 times the square root of 33 is just equal to 33. And on the top, I have 7 square root 33. Okay, now let's do tangent. So tangent of theta is equal to the opposite of the angle, which is 4, over the adjacent. So it's 4 over the square root of 33. Oops, there it is again. We got to multiply by root 33 over root 33, and we get 4 root 33 over 33. And the last one is cotangent, so I can squeeze that down there at the bottom. Let's look at our tangent. Our tangent is 4 over root 33, so let's just flip that over and make it root 33 over